We're asked to design an 8 to 1 line multiplexer using a 3 2-line decoder and an 8 by 2 and OR. So when we make this, we're going to look at the last part first. So we have this and OR and then this 8 by 2. So for this, we're going to have an OR gate, and this is going to be some large OR gate, and we'll do it over here. The reason why it's going to be large is because we have to accept 8 inputs. So this is our OR gate, and now we need to draw our 8 AND gates. And an AND gate looks like this. For this we have 2 inputs, and then we are going to have this outputting terminal right here, and we need 8 of them. And so these are all of our AND gates. Now we need to connect them to our OR gate. So they're all going to be connected like this. Now we are going to need some connections for AND gates because right now there's nothing connecting them. And so to connect our AND gates to go into the OR gate, we're going to use our decoder. It's a multiplexer. And so we can draw this. We are going to have 3 2-line. So what this is going to look like is we're going to have a rectangle, and then we're going to have 3 inputs, and then we're going to have, we'll say that they're S0, S1, S2, and this goes to A0, A1, and A2. And then we have 8 outputs. We have it as 0, 1, 2, 3, 4, 5, 6, and lastly 7. So we have 7 lines, which is really 8 lines of output. And so each of these, if we were to demonstrate it by a truth table, we could see how this would be on and off depending on what we have. And from the previous problem, it's pretty similar. We're actually going to use this same truth table. There are a few things that are different though. Instead of having an ABC, we have more of an A0, A1, and A2, but that doesn't change any of the inputs. What does change though are these. So they're no longer D, because previously we were working with an encoder, now we're decoding. So we are going to have I7, I6, I5, I4, I3, I2, I1, and I0. It's important to remember that encoding is little to many and decoding is many to little. So in the previous problem we were working with encoding, we see that we have little right here, and it will terminate to many. Now in this one, when we're dealing with decoding, we have many, and it's terminating to little. So for each of these are our AND gates, and this is our OR gate. For each of these, oh, and this is our decoder. And now for each of these, we can start connecting them. So when our A0, A1, and A2 are all low, we are going to have a high for our I0. And so that means we're going to have some, and I'll actually do this in blue. We're going to have coming out of here from the 0 to this first AND gate. And then we're going to have our I0 here. And since we have a 1 here, it's going to be high. And this will output because we have this OR gate, which will output as long as one of them is up or is high. And next we have this 1 that'll go to here. This is going to be the I1. Have the same thing here. We're going to have our I2. Same thing here. We're going to have I3. Next we have right here as I4. And then we have here as I5. And then we'll come down here. This is I6. And lastly, we're going to finish right here with our I7. And so that is how we would do this multiplexer decoder problem.